So how do you get paramagnetic tetrachloronickelate, but diamagnetic tetrachloroplatinate? And the answer is that we have two possibilities for the geometry here, and they're different. So this observation can be rationalized with the idea that tetrachloronickelate, which is paramagnetic, is tetrahedral. And so then we can imagine the 8 d electrons, 1, 2, 3, 4, 5, 6, 7, 8, would occupy the orbitals this way with 2 unpaired electrons, whereas tetrachloroplatinate, which also has 8 d electrons, would be square planar. So its orbitals might be something like this, and we could imagine them being all paired. So how do we predict whether we're going to get a tetrahedral geometry or a square planar geometry? Sometimes it can be hard to predict. Tetrahedral is more likely when the ligands are weaker field, or when delta would be, you would expect delta to be smaller, so you're going to be more likely to get square planar with the larger ions, and you're more likely to get tetrahedral with the smaller ions. But it's sometimes a little bit tricky to tell. So instead of necessarily predicting, here I'm having you explain an experimental observation, and so that skill is really more important to me.